Hey kiddos! We are going to be talking about parallel and perpendicular line, and we're actually going to go into proofs. So, kind of touching back with logic, essentially. So, let's talk about some proofs. All right, so here are a few theorems, essentially, that we can use. First one is corresponding angles converse. So if two lines are cut by a transversal, so the corresponding angles are congruent, then that would mean that these two lines J and K, would be considered parallel. Okay? Then we have alternate interior angles converse. That if two lines are cut by a transversal, so here's your transversal, okay? So that the alternate interior angles are congruent, then those lines are also deemed as parallel. We have alternate exterior angles converse, which states that if two lines are cut by a transversal, so J and K are cut by the transversal here, so that the alternate exterior angles are congruent. So if angle 1 here is congruent to angle 8, then that would mean these two lines, J, K, would be considered parallel. All right, and then we do have consecutive interior angle converse, that if two lines are cut by a transversal, so that the consecutive interior angles are supplementary. Remember, consecutive, same side is supplementary, okay? Then the lines are parallel. So you have this. These two lines would be parallel if angle 3 and angle 5 actually do add up to 180, okay? So they're supplementary. Also, don't forget about consecutive exterior angles. Okay, so example here, angle 6 and angle 7, which I just wrote in. If they are supplementary, then therefore these two lines, JK, would also become parallel. All right, so do not forget about consecutive exterior as well. Then we have the transitive property of parallel lines. Okay, so if two lines are parallel to the same line, then they're parallel to each other. So if you have that P is parallel to Q and that you state Q is parallel to R, then therefore P would have to be parallel to R as well. So P is parallel to Q is parallel to R. All of them would be parallel to each other in this situation. All right, so using corresponding angles converse, so find the value of x that makes M parallel to N, and we're going to show our work. So if we're going to state that these two lines are in fact parallel to each other, all right, then we are stating that due to these angles right here, notice they're in the same location, same spot, so they are corresponding. And we know that corresponding angles are congruent. All we would have to do then is make them equal to each other by writing 3x plus 5 equals 65. So now all we need to do is solve for x. So I'm going to draw my box around my 3x. Got to get rid of the plus 5, doing the opposite. So I'm going to subtract 5. Bring down my box so we get 3x. Those canceled out, equals 60. I notice, not 6u, 6d. Okay, notice next thing that you need to do is actually divide. And we're going to divide both sides by 3. And 60 divided by 3 gives us x to be 20. So our x value is 20. Now, if I wanted to take it a step further and verify this, I could check my work. So if I do 3 times 20 plus 5, I should get, according to this, 65. So they should both be 65, and that is 60 plus 5, and 60 plus 5 does equal, in fact, 65. So kind of a way to check to make sure that you did it right, because we know that they should be congruent. All right, next example. Example 2. Find the value of x that makes M parallel to N. Show all your work. Now, First thing we have to figure out is what relationship do these two have? I noticed that they are on the same side of the transversal, and they're located on the outside the parallel lines. So they're outside the parallel lines on the same side though of the transversal. So I know we have consecutive exterior angles, and what's special about consecutive exterior angles is that they are supplementary. Remember, supplementary means that we would add them together and make them equal to 180. So when we write our problem, we have 4 times x plus 5 plus 72 equals 180. So we're adding both of these angles together and making it equal to 180. Now notice I have a distribution problem here first. So 4 times x, 4x, 4 times 5, positive 20. Bring down the plus 72 equals 180. I can combine like terms from the get-go. So we get 4x plus 92 equals 180. And now let's actually solve. So box around my 4x. We're going to subtract 92 from both sides. All right, so I bring down what's in my box. 4x, that canceled out, equals 180 minus 92 is 88. Last step is going to be to divide by 4. So divide both sides by 4. We get x to be equal to 22. So x is 22. And now let me take it one step further. What if I actually wanted to know what is this angle? Okay, what is the measurement of that angle? All right, well, to do that, all we would have to do is plug it in to our equation or expression that they gave us. So we'd have 4 times x, which is 22 plus 5. Order of operations, so we do what's in parentheses first. So you need to add up 22 plus 5. So you end up with 4 times 27. And if we do 4 times 27, you get a grand total of 108. Now, to just ensure, so that's 108 degrees, to ensure that we did this right, if we take 108, so we got this to be 108 degrees. If you take 108 degrees and you add it to 72, we should get 180. And if you do, then you know you did it right because consecutive exterior angles are supplementary. All right, find the value of x that makes m parallel to n. So we're looking to prove that these two lines are parallel to each other. I know they're consecutive interior because they're on the same side of the transversal, which is this line here. They're on the same side, and they're located inside the parallel lines. So we should recall that consecutive interior angles are, in fact, supplementary. So that means they add up to 180. So when I write out my problem to solve, you have 3x plus 20 equals 180. Now, I am able to combine like terms first, because that is a 1x. So 3x plus 1x is 4x plus 20 equals 180. 4x plus 20 equals 180. All right, now I'm going to solve for x. So I have to subtract 20 to both sides first. And we get 4x equals 160. And then last step here is going to be to divide both sides by 4 because that's with the x. And we end up with x equal to 160 divided by 4 is 40. So x is 40. And just to take this a little step further, let's actually find out what are the actual measurements of these two angles. How do we do that? Simply by plugging it back in. So here you would have 3x, which is 3 times 40. And if we do 3 times 40, you end up with 120 degrees. All right, for the next one, you have x, which is 40 plus 20. And 40 plus 20 is 60 degrees. So clearly you can see that if you were to add those up together, 120 plus 60, you do get 180. So therefore, these two lines then are parallel. All right, so here the question is, are line AC and DF parallel? Question is yes or no. Now, we have to be able to explain our reasons. So we need to look at what type of relationship do we have here. So hopefully you guys see that this is a consecutive exterior, and we know that consecutive exterior are supposed to add up to 180 degrees. So if we add 123 plus 57, do we get 180 degrees? Hopefully you are saying yes, because that is true. So therefore, because that is true, we can actually state that line AC is actually parallel to line DF. All right, same type of problem. Are AC and DF parallel? So is line AC, which is this one here, parallel to DF? Yes or no? So let's see what we have here. Ooh, okay, right off the bat, I don't have any that I actually know, because that's not really, they're not same side. They're alternate, but one's inside and one's outside. So I have to use some other knowledge that I have here. And hopefully we do recall vertical angles. So if I state that this is 143, then I should know that this would have to be 143. Okay, so that's 143. And now if I look at these two, I know that those are consecutive interior angles. Okay, so notice I use my knowledge of vertical angles, and then now I'm using consecutive interior angles. Okay, so those are my two reasonings. All right, and what we know about consecutive angles are that they're supplementary. So is 143 plus 37 180? If the answer is yes, then those two lines are parallel. All right, I want you guys to do this one on your own. Same kind of situation as the other two that I did. So we're trying to figure out if AC is going to be parallel to DF based on what you are given. And another problem for you guys to do on your own. Notice you do have the visual here. The diagram of the control bar of the kite shows the angles formed between the control bar and the kite lines. How do you know that N is parallel to M? So, what reasoning can you give for this to actually be, for these two lines to actually be parallel, based on the information that they gave you here? All right, list the four theorems that can be used to conclude that J is, in fact, parallel to K. So, proving that J is parallel to K. All right, first theorem is if corresponding angles are congruent, then the lines are parallel. So, give me an example of two angles that are, in fact, corresponding. Let's see. We can go with angle 1 and angle 5. They're in the exact same location, so they would have to be congruent. And we can also say angle 4 and angle 8 are corresponding, so therefore that can be proof that these two lines are in fact parallel. All right, next theorem, if alternate interior angles are congruent, then the lines are parallel. So an example would be angle alternate interior. So remember, going interior, so we got to look at the ones inside of the parallel lines. So I would say angle 2 is alternate interior with angle 7. And the other example would be angle 4 is alternate interior with angle 5. Third theorem, if alternate, this time exterior angles are congruent, then the lines are parallel. So alternate exterior, okay, so we're looking outside of the parallel lines. And I would say we could have angle 1 is alternate exterior with angle 8. And we can also state that the other pair would be angle 3 is alternate exterior with angle 6. And the final theorem here is about consecutive. So if consecutive interior exterior, okay, I just put them together, okay, angles are supplementary, then the lines are parallel. So let's give an example of an interior situation of consecutive. So that would be inside of the parallel lines on the same side. So that would be angle 2 and angle 5. And as long as they add up to 180, then those two lines would be parallel. And the exterior example could be angle 3 and angle 8. If those two were to add up to 180, then those two lines would be proven to be parallel. All right, so just to talk about a few other things that you can use as proof is for proofs, distance from a point to a line. So the length of a perpendicular segment from the point to the line, the perpendicular segment is the shortest distance between the point and a line, okay? So do recall that, okay? Perpendicular segment's the shortest distance, all right? So example, the distance between point A and line K is AB. So drawing a line like this or like this, these two lines that I just drew would not be the shortest distance or quickest way to get to line K. That's what this is stating. Perpendicular bisector. Okay, bisector, that's a vocabulary we've heard before. Remember, it basically creates two congruent parts or pieces. Okay, that's what bisecting means. It cuts something into two congruent pieces. So the perpendicular bisector of line PQ, or I should say line segment PQ, is the line N. Which of the following, with the two following two properties? So N, notice this upside down T is a symbol for perpendicular, okay? So line N is perpendicular to segment PQ. And N then ultimately passes through point M, which is known as a midpoint for segment PQ. All right? So it would create this segment PQ to be congruent pieces. And it still also then creates that 90-degree angle at the intersection. Perpendicular transversal theorem. In a plane, if a transversal is perpendicular to one of the two parallel lines, then it is perpendicular to the other line. So if it's proven that it is perpendicular to one line, so notice here we can see that line J is perpendicular to H because of the marking right here, then it is fair to say that that same line would also then be perpendicular to line K because these two are parallel. Lines perpendicular to a transversal theorem. In a plane, if two lines are perpendicular to the same line, then they are parallel to each other. So because line M and line N are perpendicular to line P, then we would have to state that these two lines, line M and line N, would have to be parallel to one another. All right, so finding the distance from a point. Now, what I have done here is I've used Pythagorean theorem because I have a visual. All right. So to find AB, I created this right triangle. Sorry, let me draw it in. All right, so notice I count my units. That is 6 units and 2 units, so hence why I have 6 squared plus 2 squared. And when we actually work that out, 6 squared plus 2 squared, you get 40. And then to solve, so you get 40 equals c squared. And we know the last step would be to take the actual square root of it. And when you take the square root of 40, and we're going to get a decimal answer, we get 6.3 units. All right, now let's look at AC. AC is this line here. So I did this right triangle, and you'll see it in red. Okay, so notice I got 4 units and 4 units. So 4 squared plus 4 squared gives me a grand total of 32 equals c squared. My last step is to take the square root of that. And the square root of 32 is going to round, if I round to the 10th here, to 5.7. And then the last one that we have is AD. And AD is here, so this is the, whoops. Here's the right triangle I drew for that, AD, right there. Okay, so there's that right triangle. And those measurements were 5 and 3. So I get 5 squared plus 3 squared. So 5 squared plus 3 squared is 34. So I get 34 equals c squared. And if I take the square root of that, 34, so square root of 34 gives me 5.8. So which distance is the shortest then from point A to get to our line here that we have? Hopefully you guys see that that shortest distance was the 5.7 units. So the observation that you should have made is that the shortest distance was the path that is perpendicular. Okay, and notice we can see that this line is perpendicular by the marking right here. All right, so our next example, we're going to find the value of x when line A is perpendicular to line B, and line B is actually parallel to line C. So I'm going to make a few markings here. We said that line A is perpendicular to line B, and that line B is parallel to C. All right, notice I did make a change to the problem, so please scratch that out and make this change. Okay, and do note that these two are located in what position to each other? What relationship do these two angles have? Hopefully you see they're on different sides of the transversal, and they're on the outside of the parallel lines, so that would make them alternate exterior angles are congruent. So if we use that information to solve, we can write that 3 times 2x minus 14 would have to be equal to 4x plus 2. Another approach that you could take is that knowing that this is 90 degrees and that these two lines are in fact parallel, that these two angles, yes, they are congruent, but we actually kind of already know what value they're supposed to equal because of this perpendicular situation, which means that's 90 degrees, meaning that all of our angles here consequently are actually going to be equal to 90 degrees when you have that kind of situation. But we already have it written out this way, so let's go ahead and solve this one this way. So I notice I have distribution. So you have 6x and 3 times negative 14 and negative 42 equals 4x plus 2. I got x's on both sides. It's no bueno. So I'm going to subtract 4x to both sides. Notice I wrote it underneath the 6x because those combine to give us 2x. Minus 42 equals, they canceled out, 2. Solving for 2x here, solving for x, I'm going to add 42 to both sides because I'm trying to cancel what's beside my box. And you get 2x equals 44. So 2x equals 44. And if I do the last step, which is divide by 2, x equals 22. Now, just to confirm that we actually end up with 90 degrees, let's take this angle here, all right, and see if we can substitute in what we found for x and see if we actually get 90 degrees. So 4 times x is 22 plus 2. So 4 times 22 is 88 plus 2 does give us our 90 degrees. Okay, next example. Determine which lines, if any, must be parallel and explain your reasoning. So, you're having to probably look back at our proofs that we have for parallel lines to help you with this problem. So, one thing that I do want to note is I do see that line Z looks to be perpendicular to line X, and line Z is also perpendicular to line Y. So I can easily state that. And because line Z seems to be perpendicular to X and Y, then that would lead me to believe that X would have to be parallel to Y because of the lines perpendicular to a transversal theorem. All right, let's look at the next one, B. I can see here that they've given me that line Y is perpendicular to W and that line X is perpendicular to Z. That's all I really can go off of, and they don't share anything like they did here. So therefore, in this situation, I'm actually going to say we can't prove that there are any parallel lines because there's not enough information given. All right. Next situation. All right. So I can see here that I have line B, and I see that it's perpendicular to line L, and line B is also perpendicular to line N. All right. So there's a relationship right there between those two lines. And then I do note also that line A is perpendicular to line M, and line A is perpendicular to line N. So we can conclude then that A and B would have to be parallel. And we actually have another situation. L, M, and N are in fact all parallel to each other. Reasonings are the line perpendicular to transversal theorem and the transitive property of parallel lines. Next one. Okay, so remember you're trying to find and link information out. So if you need to write out things like A is perpendicular to M and A is perpendicular to N. So that way you can actually establish the different relationships. It makes it easier, then please do so. Okay, so D. All right, I see that line A is perpendicular to N, and line B is perpendicular to N as well, and line C is perpendicular to M. So that's all I really have. So I notice A and B have N in common, so I'm thinking that A would have to be parallel to B. Okay, notice, remember, they kind of had something in common there. So reasoning, lines are perpendicular to a transversal theorem. So notice it does help if you actually write it out. You see that they have something that they share in common. All right, awesomeness.